Alright, so this is the last video in this chapter where we're looking at non-linear data and how we can make it more useful. So as you can see, if we have an exponential function ax to the power of n, then the graph itself we know is exponential function graph looks something like this. However, apart from where it crosses the y-axis, there's not much useful information we can actually determine from this, right? What's better is for us to convert this into a straight line graph. In that way we can find a gradient and we can find a y-intercept, and there's a lot more information that we can determine. So we're going to change this into a straight line equation form where we have y is mx plus c. Right, so there's actually two different cases. Let's start off with this one here. So y is equal to x to the power of n. So I'm going to use the log rules to manipulate this a bit. So I'm going to apply logs to both sides. So log y is equal to log ax to the n. Now I'm going to use the log multiplication rule to split this up into log a plus log x to the n, and then use the power rule to bring that n down, so bring n log x, and this is still all equal to y. And as you can see now, it's actually in a y is mxc form, because I can say that, well, this is going to be my y value, this log x itself is going to be my x value, making this log a as y-intercept and this n our gradient m, like this. And so if I was to plot a graph, a straight line graph, then on the axis I'll have log y on the y-axis, I have log x on the x-axis, and it'll be a straight line graph where the gradient will be equal to n and the y-intercept will be equal to log a. So therefore I can find my gradient, I can find my y-intercept, and therefore I can find my a and n values. Right, as I said, there's two different cases. That's the first case. The second case is when we have a slightly different form of the exponentials, where we have y is equal to a n to the x. So you can see it's slightly different, right? So I'm going to do the same thing there. I'm going to apply logs to each side. So log y is equal to log a n to the x. Use the multiplication rule, log a plus log n to the x. Use the power rule, log a plus x log n, and that's equal to log y. Now compare this to straight line equation, y is mx plus c. This will be my y. This x now will be my x. So therefore this makes my gradient m, and this is my c. So now if I was to plot the graph, a straight line graph, my y-axis will still be log y. My x-axis would actually be just x, and it'll be a straight line equation where the y-intercept will be log a and the gradient will now be log n. So as you can see, depending upon the case, the gradients and the x-intercepts or the x-axes are slightly different depending upon the original form of the exponential. So with this, let's try and solve this question here. So we have a scientist modeling the number of people who have fallen sick with a virus after t days. And as you can see, he's got the axes log n and t, okay? And so therefore we know it's in the form, in this case, n is a, b, t, okay? That's what they told us. And they've said the graph passes through the points 0, 1.6 and 10, 2.55. Write down the equation of the line. So it's a straight line equation. So the straight line equation, log n is equal to, the y-intercept is 1.6, right? So 1.6 plus the gradient we should need to find. So the gradient is going to be changing y with changing x, so 2.55 minus 1.6 over 10 minus 0, which will give you 19 over 200. So it'd be 19 over 200 times by t, like this. So this is the straight line equation that they asked for. Using your answers in part E, find the values of a and b, giving them to two significant values. So as you can see here, we're trying to find a and b. So you need to be aware of what's equal to what. So as we said earlier, this is here is going to be equal to log a, right? Okay. And you need to be aware which one is going to be. So if you go like here, it's going to be in this form here, right? So therefore the gradient is going to be equal to log n, meaning that the gradient this is equal to log, in this case not n, but in this case log b. So I can say that 1.6 is equal to log a, and 19 over 200 is equal to log b. Now I just have to find a, so a is just going to be, remember if there's no base here, you can just use the base 10, okay? So a is going to be 10 to the power of 1.6. And b is going to be 10 to the power of 19 over 200. And they're set to two significant figures, so this will be 40 and b will give you 1.2. So as long as you know what the gradient is equivalent to, then you can work out using logs the values of a and b. Right, C, interpret the meaning of the constant a in this model. So as you can see, if I was to write it out, it'll be n is equal to 40 times 1.2 to the power of t. So our a value is this 40 value here. And what this means is, well, if t is 0, right, this term becomes 1.2 to the t becomes 1, right? So n is 40 is essentially just the initial number of people who have, in this case, gotten sick. Okay, so that's the initial number of people who gotten sick at time t is 0. D. Use your model to predict the number of people sick after 30 days. Well, just have to plug in t is 30 to this equation here, and then you find the n value. So the latter questions are not too difficult. It's initially trying to determining what the gradient is equal to, and then what the y-intercept is equal to. Let's just try one final one. So we have a student who's investigating a family of similar shapes. She measures the width w and the area a of each shape, and she suspects that the formula is in the form a is p w to the q. So the variables here are w and a, right? And she says the graph passes gradient 2 and minus 0.149. Write the straight line equation. So I can change it to straight line equation. So I can say log a is equal to log p wq. If you don't remember the initial one, you can just do it yourself. So this will be equal to q log w plus log p. So log a is equal to this. So I just have to now input my q and p. So log a is equal to q will be the gradient in this case. So gradient they've told us is 2, so it'll be 2 log w, and it passes through log p, which is a y-intercept, so in this case minus 0.1049. B. Starting with your answer to A, find the exact values of q and p. Well, as we just said, q is just 2, right? So that's easy. And log p is equivalent to this here. So I can say that log p is equal to minus 0.1049. Therefore, p is equal to 10 to the power of minus 1.049, which will give me a value of 0.7854. Okay, so as I said, the straight line equations are much more useful than an exponential equation, just to find certain values. Even though exponential functions are useful for actually modeling. So this is the last chapter of the Pure 1 book. Okay, so as you can, So this is the last chapter of the Pure 1 book. We're going to be moving on to Pure 2, and we're going to also do the stats and mechanics part in the later videos.